All right, so in this chapter, we're going to look into modeling. And what I mean by modeling is basically building some sort of a mathematical structure that models something in the real world. All right, now when I say structure, typically in this class, we're going to build an equation or an expression that emulates a real life situation. Now, it turns out that there's a lot of other areas of mathematics where when they build a model, it might not be an equation, it might not be an expression, it might be something more complicated. But for the purposes of this class, we're talking about just building expressions or equations that emulate real life situations. Now, the important things to know, well, there's three things that we're going to have to look at. First off, what kind of a situation are we in? Are we in a situation where we have linear growth or exponential growth, or do we have a parabola, which is a quadratic function? Things of that nature. So what kind of situation we're in. And then we need to figure out how to find a best model. Certain times you can actually build one from the situation. All right. Certain times there may be a formula that's sort of already in place that gives you a model for that. Other times you might have to think of the formula. And after we've found this formula or whatever, we always have to ask ourselves, how well does our model fit? Okay, because there's a lot of times in real life that even though our models may be good, they might not fit perfectly. And they might be varying levels of goodness. For instance, certain models are going to fit exactly. And so for every piece of data, we know exactly how the outcome is going to be. So in other words, for every single input, my output is going to be perfect. Okay? Others, there's going to be some play. So we have input and outputs, but your output that the model gives may just be close to the output you get in real life. Okay? A lot of times when we talk about economic models, that people don't tend to get exact models when they're dealing with economics, because there's a lot of variables, there's a lot of factors in play when you, for instance, raise or lower the tax rates and see how that's going to affect GDP next year. Those types of things. All right. So when we do have exact fit models, when we do have those situations where the fit is exact, like cases of those would be sort of like when we model a physical phenomenon, right? So if I'm talking about distance, rate, time of a car, a car is traveling 60 miles per hour for 2 hours. How far did it travel? Those kinds of things. Or if we're talking about another exact fit, would be things like areas of rectangles and circles and the standard geometric type models. Also, something that we've seen before in this class are models which can model interest or monetary ideas, things that have to do with money. Because when you put it into a bank, the bank is going to give you, exactly whatever percent interest you get. All right. Now, when you put it in the stock market, then that's a little bit trickier. But if you put money into the bank and they say they're going to give you 5% interest compounded monthly, then you can fit a model exactly to that kind of a data. But many times in life, the data that we get isn't pretty. Okay, there's a lot of times in life where you want to try to develop a model, and maybe you're going to have to base that model off of data that you've collected. All right, like for instance, what's the temperature going to be tomorrow. Now, we have a pretty good idea of what the temperature is going to be tomorrow, but you know, the weatherman's working based off models and things like that, and using data, and whatever the estimate that gives out, it might not be exactly what actually comes out of the actual weather tomorrow, because there's so many variables, there's so many things that they have to take into account. And so a lot of times we have data which is sort of scattered. It's hard to decide sort of what models we pick, right? So if we had a perfect line, that would be nice, but a lot of times we don't have perfect lines. A lot of times our data comes back and it looks, you know, in this way. And so a lot of times we go to fit a model in, so say we build a line for this data, and so the data points are scattered, the line doesn't necessarily fit exactly. All right. And so we're going to look at those models and exact models in this chapter, and we're going to do a very short, brief introduction to this, and like most things in this course, this sort of opens itself up to a lot deeper, a lot more analysis. In fact, there's 500 level courses which are dedicated to trying to find, you know, models that fit exactly and not exactly and those kinds of things.